Hi everyone, let's go ahead and start on our review for the Unit 2 test. Okay, so the first one we want to be able to convert to scientific notation back and forth between decimal notation. So if I have 7.6 times 10 to the third, then this tells me I have to take the 7.6 and move the decimal to the right 3 places, fill in with zeros, so that becomes 7,600. Remember, a positive exponent is going to be a number larger than 1. A negative exponent is going to be smaller than 1. Okay, if I want to go backwards, if I want to convert to scientific notation, I need to write it where there is 1 digit to the left of the decimal. So I will start out at 5.96 times 10 to some power. Since this is smaller than 1, this is negative, and I move the decimal 2 places. So it's 5.96 times 10 to the negative 2. Okay, if I'm multiplying, then what I want to do is I want to multiply the 1.75 times 4.20, which gives me 7.35. So I'm going to multiply these two. And then I also want to multiply these two. So 10 to the negative 3 times 10 to the negative 5 means I add those exponents, so that becomes 10 to the negative 3 plus negative 5, which is 10 to the negative 8. Now, as I write this in scientific notation, this has 1 decimal to the left, so I'm good to go. So this just becomes 7.35 times 10 to the negative 8. If this had not had 1, if it had been 73.5 or something of that nature, or 0.735, I would have had to convert this as well. Okay, here I am going to divide this. So I'm going to take 1.6 divided by 6.4, which gives me 0.25. I'm going to divide here 10 to the negative 2 divided by 10 to the negative 7, which becomes 10 to the negative 2 minus negative 7, which is 10 to the 5th. So I start out with 0.25 times 10 to the 5th, but this is a problem. So I have to take this, and I'm going to have to write this in scientific notation. So I move this over here, so this becomes 2.5 times 10 to the first times 10 to the 5th, which ultimately gives me 2.5 times 10 to the 6th. Okay, simplifying exponents, and it says no negatives. All right. So there's always multiple ways to do this. I think what I'm going to do is on this one, I think I'll take care of my x's, my y's, my z's, and then I'll figure out from the results what goes in the numerator and what goes in the denominator. So for my x's, I have x to the second times x. For my y's, I have y times y to the negative 2. And then for my z, I have z to the negative 7 times z to the third. So this gives me x to the third, y, if I have 1 minus 2 to the negative 1, and z to the negative 7 plus 3 is negative 4. So now I have to take care of the whole negative exponent thing. If it's negative in the numerator, it moves to the denominator and vice versa. So my x to the third can stay where it is. My y to the negative 1 has to move down here as y to the positive 1, and my z to the negative 4 to make it positive goes in the denominator. And there's my final answer. Okay, now this one again, you can do it a couple of different ways. You can simplify what's in here and then take it to the fourth power, or you can do it a different way. I think I'll simplify this, get rid of my negative exponents, and then take everything to the fourth power. So this is going to become 2 to the fourth, p to the fourth, q to the second to the fourth, r to the negative 3 to the fourth. I'll make sure I got all of them. 2 to the fourth is 16, p to the fourth, q to the eighth, and r to the negative 12. So now the only thing I have to worry about is this. Since this is a negative exponent, when I write my answer, this becomes 16 p to the fourth q to the eighth divided by r to the positive 12. And there's my answer. Okay, let's see what I can do with this. All right, so I'm going to have to take care of this bit by bit, and this print here is really small. So I know I'm going to end up with a fraction, and who knows what's going to go in the numerator and the denominator. But I'm first going to take care of this 12 over 27. 12 over 27, they're both divisible by 3, so that becomes 4 over 9. My x's, if I have 1 minus 4, that's negative 3, so x divided by x to the fourth is x to the negative 3, which is 1 over x to the third, so my x's go in the denominator. My y's are fine, so my y to the eighth can go in the numerator. And finally, my z to the negative 3, 1 over z to the negative 3 equals z to the 3. So I'm sorry, to the 2, excuse me. So z to the second goes in the numerator. And there's your answer. Okay. This one, I think I want to clear up everything inside before I start dealing with this. So in my first step, I'm going to make it to the negative 2. All right, 8 over 28. They are both divisible by 4. So that becomes 2 over 7. For my x's, I have x divided by x to the second, which leaves me with a single x in the denominator. For my y, I have y to the third over y, which is y to the second. In the numerator. And then my z's, I have z to the -2 over z to the 5th, which gives me z to the 7th in the denominator. Okay, so now if I take everything to the -2, that means I'm going to flip it upside down to the second power. So this becomes 7x z to the 7th over 2y to the second. 7 to the second power is 49. X to the second. 7 times 2 gives me z to the 14th. 2 to the second is 4. Y to the second squared is y to the 4th. And there you have it. Okay, perform the operation and simplify. Okay, of course, the simplification on this, we want to combine our like terms. And you can do it vertically or you can do it horizontally. I prefer just to find my terms. So I'm adding, I don't have to worry about it. 2x to the second plus x to the second gives me 3x to the second. Negative 3y minus 5y gives me 8x, excuse me. 4 minus 10 is -6. And there you have it. When I'm doing a subtraction problem, what I really like to do is change this to addition. So this becomes plus 2x to the second minus 4x plus 5. So I'm kind of done with that now. And now I can just combine my like terms. So I have negative 3x to the third. There's nothing I can combine with that. 4x to the second plus 2x to the second gives me 6x to the second. Negative 2x minus 4x gives me negative 6x. And 1 plus 5 gives me 6. And there's the final answer. Okay. Now for this one, if I'm multiplying, especially if I'm multiplying a 2 terms time a 3 terms, I want to use the boxes or the area model is what I've always called it. So I'm going to have 2x minus 5, x squared minus 3x plus 4. So this gives me 2x to the third minus 6x to the second, a positive 8x, negative 5x to the second, plus 15x minus 20. And you will see if there are like terms to be combined, then they will be on the diagonal. So my answer becomes 2x to the third minus 11x to the second plus 23x minus 20. Okay, x plus 2 to the second, of course that means x plus 2 times x plus 2, so you can FOIL it out, or you can think about it in terms of the perfect square pattern. So this becomes x squared plus 2x plus 2x plus 4, which is x squared plus 4x plus 4. Okay, so let's talk about factoring. Now, factoring, remember you've got that strategy. The first thing you want to look for is a GCF, and then look at the number of terms. If you have 2, 3, or 4, and determine what to do with that. Okay, so that's kind of what we'll do on these. We'll start out by always looking for the GCF. And if there is one, we will factor it out. Okay, so let's see. And also, I want to factor out the negative sign. So I know I'm going to factor out at least a -1. So my GCF is -3. I have an x in common and I have a y in common. So this is -3xy. And when I divide by that, I get 5x minus 3. 5x minus 3 can't be factored, so I'm done. Okay, so I've got 3 terms here, and so the first thing I want to look for is a greatest common factor. Well, they all have an x and they all have a y, so I know I'm going to be able to factor out an x and a y, and for the numbers, the GCF is 7. So when I factor that out, I'm left with 2x plus x, I'm sorry, 2x squared plus x minus 1. Okay, so now I want to see if I can factor that. Yeah, this is what's different is written differently than on the key, so I'm going to go ahead. That's why it's taken me a while is checking my answers. All right, the leading coefficient is 2, so there are 3 terms I'm going to split and group. So I'm looking for 2 numbers whose product is -2 and whose sum is 1, and of course they are -1 and 2. So I'm going to take this and write it as 2x squared minus x plus 2x minus 1. And I want to remember to include this, but I'm going to have to take this and move it up here. So I'm going to group this. So this gives me x times 2x minus 1 plus 1 times 2x minus 1, which gives me, I'll write it down here, 2x minus 1 times x plus 1, and include my GCF of 7xy. Okay, this is 4 terms, so I'm going to look for a GCF. There isn't one, so now I can factor by grouping. So I'll just go ahead and group and see what happens. So the greatest common factor here is x, and I'm left with x squared plus 4. Then I have a plus 1 times x squared plus 4. So I have a common binomial factor of x squared plus 4, and I'm left with x plus 1, and that's my final answer. Okay, I'm going to pause here.